Hello again, my name is David Watts from Lenovo Press, and today we're going to be talking about the new ThinkSystem SD650. And I have with me today Scott Holland. Scott is one of the thermal engineers here in the lab. How are you doing, Scott?
I'm doing well today. How are you?
So we're in the one of the development labs here in Morrisville, North Carolina. We're going to be talking about this new water-cooled system. Scott, what else goes on here in this lab?
So we do, thermal engineering work. We design cooling solutions for, several of the DCG products, specifically the SR950 as well as the water-cooled offerings.
Yep, so that's what we're going to be talking about today?
Yes.
So what we have here is the water-cooled solution. I would point out, before we go too much further, is that this is a fully operational rack. All of these servers, with only a few exceptions, they're all on and all running at maximum performance. And yet we'll still be able to have a regular conversation here. And that's really one of the big advantages of a water-cooled system. If this was an air-cooled rack, right, we would not be able to have this conversation, right?
Right, not at this volume anyway.
Yeah, we'd have to be shouting at each other.
Correct.
Yeah, and when we go around the back of the rack, you'll see it even more so. Yeah. Okay, so what we're looking at here is the front of all these servers, and the water-cooled solution is set in these 6U enclosures. This is a standard rack, and in each 6U enclosure is 12 servers on 6 trays. Yep?
Correct. Right.
Now, Scott, what's the rest of this? What's going on here to cool the system?
Right. So, like you said, we have 6 enclosures in this rack. So this is a 42U rack standard. So as part of our data acquisition, you'll see all these wires, these thermocouples, we call them these brown wires. So this is what we use to measure component temperatures, as you can see. So this is not what you would see.
Right, we're in a development lab and these systems are being developed.
Correct.
Yep.
So this is some development infrastructure that we designed and built here at Lenovo. This allows us to measure the pressure drop across the rack, as well as temperatures, as well as control the flow rate to the rack for different experiments.
So as part of development, you're using this environment to go through various test cases.
Correct. Yeah. So we just have this connected to our cooling distribution unit, which is actually providing the flow rate, the pressure to actually move the water through the rack, as well as cool the rack using our facility water.
Right.
So
this is part of a regular production system, the CDU.
Correct. This is very typical of what you'd see in a data center.
Yeah. Okay. Yep. All right. So, and the water flows from the CDU and through underneath the rack to the back of the rack. That's where the water comes into the servers. So let's go around the back there and have a look at where that water is fed in. All right. So here we are at the back of the rack now. Now the water comes from the CDU and is fed through hoses at the bottom of the rack, and then fed to the individual chassis. So Scott, how's the water distributed?
Right, so we utilize these 6-drop manifolds in this example. So each chassis has its own supply where the water is then split again. So we have supply coming from our CDU that we discussed earlier that supplies flow to all 6 chassis in parallel flow. So this is what's actually attached to the chassis. This is our manifold. So flow from the CDU comes in from the bottom and is then distributed through these 6 parallel plugs. This allows us to supply the flow from the CDU to the servers without having to come to the back of the rack for any service. And
you've designed these couplings so that you can actually pull out a server while everything's running. All the water is still flowing, right?
Correct. Since the beauty of it being in parallel is that by breaking one connection, it doesn't compromise the rest. Think of new Christmas lights compared to old Christmas lights.
Yes. Yeah. Okay.
Right.
Yeah.
So again, this is mounted, rigidly to the midplane in the back of the chassis, as you can see, and this allows us to dock and undock.
And so there's one hose that brings water in to the servers, and then the other one is for taking the water out.
Correct. This is the return side. So after the water's done its job and absorbed heat from the servers, it comes out somewhat warmer than this one measurably, and then returns to the CDU.
And customers can use that water, that warmer water, for other environmental purposes, right? For heating.
Correct.
Yeah. So it's not like the heat is actually not being put to good use if you want to.
Right. You have the option to repurpose this heat. It does reach temperatures that are useful in terms of reutilizing heat.
And we're talking about capturing about 85-90% of the heat from within these servers?
Correct. 85 to 90% of the heat that's generated by the server is absorbed directly by the water, as opposed to an air-cooled system that would need chassis fans in the system to
Right.
eject the heat to the room.
So each of these blanks here, this is where the fans would be if we had fans. We have an air-cooled variant of this that has fans. The only fans that this enclosure have are the power supply fans. Each enclosure has 6 hot swap fans, and each of those fans has a small fan inside it that provides any additional heat extraction that might be needed by some of the other components.
Right.
Yeah. In addition, I would point out too, there's a thing called the FPC. This is a sensor fan and power controller, and it is the controller that you would use to provide management of the enclosure. So there's an Ethernet connection for that. You would have one of those for each of the enclosures in your rack. All right. So that's pretty much all there is in the back. So let's go back to the front and pull out one of those and have a look inside.
Sounds good.
All right, so we're back at the front of the enclosure now. Actually, before we open up, pull one of the servers out, tell us what sort of customer would be best suited for this sort of environment.
Right. So what this server allows us to do is we can cool very high power loads very efficiently using the water. So that becomes valuable to customers who are trying to really be green. Some of the green top 500 list, as well as floor space is limited and you need more compute. This is a very dense solution. We have up to 45 kilowatt racks with this solution with very moderate flow rates, and you can achieve acoustics like so. So HPC customers are very interested in this technology. Academia has been a popular environment.
Yep.
And there's some customers who don't necessarily need the density, but their data centers, their HVAC's been tapped out. So the only way they can put more compute into their data center is to actually remove the heat via the water. An additional benefit of the water-cooled servers is we can maintain higher frequencies longer due to maintaining lower lid temperatures, as the liquid cooling is a very efficient cooling compared to the air-cooled equivalent.
All right, so significant density of compute power, heat removal, heat management, and greater performance.
Correct.
Yeah, excellent. All right, so let's pull one of these servers out and have a look inside.
Okay.
Yeah.
So I've already shut down one of the servers, in preparation. So your service action would be to remove your I/O connections from the front after you've shut down the server. So I'm just going to break the management here, and then we're just going to undock the server using the 2 latches.
And the rest of them are still running. The water is still flowing back there. The couplings at the back are designed so that the water will simply shut off from this tray, and the rest will keep flowing.
Correct. We've disconnected power and water, so there's been no dripping, no leakage in the back of the server. So all your services completed from the front.
Yeah. All right. Great.
So now we just open the tray.
Alrighty. Okay, so here are our water connections. So this is the inlet water for the tray, and then the water comes out of this one.
Correct.
Yep. And what you're looking at here is 2 completely separate, isolated servers.
Correct.
But what they share is common cooling and common power.
Correct.
Yep. Okay, so Scott, take us through how the water flows through the components.
Right. So as you mentioned, we have our supply and our return on the server, and so we have we distribute the flow evenly between the 2 servers, and then within the server we distribute the flow again between the processors and the memory, and this is done to maximize the cooling on higher TDP processors for future designs.
And the water flows through there and goes to the front components as well, right?
Correct. So if you can imagine, it's hard to see with everything configured, but we're actually sending the water through the memory, and then it goes through this front portion before returning through the memory, and then similarly it goes through the CPU's cold plates and through. And
a parallel set of lines goes through the other server.
Correct. The flow path is identical between the left and right.
Yeah. All right. Yep. Now you removed just then 2 plastic covers for the around the DIMMs. What's that for?
Right, so these plastic covers not only insulate the memory to maximize the heat recovery to the water, but it also provides some compression to ensure that there's good contact between the memory and the water lines.
Together, yeah. Okay.
Correct.
Yeah, the pink substance, that's what you can see is where the copper lines are running through. That's the heat transfer substance, right?
Correct.
Is there a name for that?
It's called gap pad.
Yeah, okay.
And it's just conforms to the irregular topographies of the memory, so we can get all the heat possible.
Yeah, okay. Now, each server has two processors. These are the Intel Xeon Scalable family processors. What we're looking at here right now is servers that processes up to 205 watt TDP.
Correct.
The server is designed to support greater TDP. Should Intel come out with those, so
right?
There's some headroom there. Now, as well as the regular Intel Xeon Scalable processors, this server also supports the F-style processors that have an embedded OmniPath fabric. And for us to show you the difference between those, one has a little connector on the end, and one does not. So, we'll talk about how those are used in a moment. But the key thing is that this server supports both regular scalable family processors and the F-style, the F SKUs, which have the built-in embedded fabric.
Yes.
Yep. So the water cooling, the cold plates are connected directly to the processors, right? That's one of the key benefits of this.
Right. It's called direct water cooling. So that means we're directly, forcing the water over the component to be cooled.
Yeah.
Right.
And moving towards the front of the server now, you've got each server has a PCIe slot and drive bays.
Correct.
So let's talk about the PCIe slot first, shall we?
Sure.
Well, it's a PCIe by 16, PCI 3.0 by 16 slot, and supports high-speed networking cards.
Correct.
So what have we got there?
So today we have, just to show the variety, this is our Mellanox Connect X5 card today. And then on this half, you'll see the Intel OmniPath card. Mm-hmm. So both these are 100 gigabit cards today, single port.
Now the difference I can see, one of them has a regular heatsink, and the other has a copper pipe connected to it.
Correct. So we've enabled solutions for both. So we support a standard air-cooled PCIe card, but if the end user wants to maximize their heat recovery and maximize the effectiveness of the water, we've enabled a solution to actually transport the heat from the ASIC on the PCIe card directly to the water without actually having to run water to the card.
And is this a solid pipe, or is it hollow?
So it's actually got a wicking structure inside and a small amount of fluid. And what it does is, if you can visualize, you'll see that it's completely sealed on both ends, so it's encapsulated. And what this does, it allows very high heat transfer to occur between the hot source, which is the ASIC, and then it allows us to pump the heat directly to the water line. So this portion is actually mated to the water without actually ever having to connect. And this provides enough cooling to cool this card, as well as extracting the heat from the card and then, placing it into the water.
So for customers that are looking to maximize the heat transfer to the water system, this is the sort of car they want.
Correct.
Yeah. Yep. Okay, excellent. Alrighty. Now, as well as regular PCIe cards, we also support, for OmniPath, we also support the IFT pass-through.
Correct.
Now, explain how that works. We've got processor. So this is what I mentioned before. This is the use of the Intel processors with the embedded fabric.
Correct.
The F processors, if you like. So they have this connector that sticks out the back, and the processor is aligned this way in the server.
Right.
And that's the IFT card you have there, the interposer.
Right, so this enables the solution. So what this does is it allows us to connect directly to the connection on the processor. And what this does is it allows us to run the I/O to the front of the server. So this just installs like a standard PCIe card here, and it allows the traffic to be routed to the front. And there's a connection for each CPU. So there's
one for front processor and one for the back. Yeah.
Correct. And so this would just simply lock in place, like so.
So these are directly connected to the processor.
Correct.
Yeah.
So this removes the need to have a separate PCIe card, which again is some cost savings.
Right. Okay. So a customer would use this if they're wanting to save some cost on the solution. Other than that, they're the same ports, right? It's the same card. Other than that.
Yes.
Yeah. Okay. Alrighty. Now, next to the I/O card. I/O slot is the drive offering, right? Now, what we have here is 2 SSDs or NVMe. The server supports 2 of the 7mm SSDs or 1 15mm SSD here. And this one is the NVMe connection.
Yes.
The service either supports SATA or NVMe.
Correct.
Yeah. So let's open up this one, have a look and see how it works, right?
Right. So, keeping serviceability in mind, we designed a toolless design to service the drives. So we can actually extract the drive without needing any tools. So what we do is that we actuate the drive cage to nut position, and then we can simply eject the drive like so.
Oh, now, this is a regular drive. There's nothing special about these. What's interesting is that the cooling mechanism, right?
Correct. One thing we've enabled on this design and developed here at Lenovo is a design to cool the drive using the water. So we're actually running water directly underneath the drive, and using the same material that we're using on the memory, we're actually able to cool the drive by pulling heat from the bottom of the drive, which allows us to cool, very high TDP processors with very modest airflow. Excuse me.
Yeah. Now the server also has a design for an ML2 slot. So in the future we can bring out ML2 offerings as well. There is a slot for that purpose there, and it would go in the same bay area as the drive, so it's one or the other.
Correct.
Once we come out with ML2. Yeah. Okay, so that's the components there. Now, actually, we forgot to mention the servicing of the DIMMs, right?
Yes, we did.
Now, the DIMMs are very closely spaced together to maximize the heat transfer, but of course that means it's a little bit harder to get the DIMMs out.
Right.
So what have we done there in that?
Right. So as you can see, we have several water lines going between the memory to maximize the cooling. But as you can see, if you want to service a DIMM, you have to. It appears you'd have to remove the entire cooling solution to access the memory.
You just can't get your fingers in there to push those buttons.
Correct.
Yep.
So we understand that the end user, that's not a very practical service model. So what we've done is we've designed a DIMM removal tool that we ship standard in every server.
In fact, you ship two of them, right?
Right. We have redundancy.
Yeah, love it. Yeah.
Right.
So that's actually just there's a little mounting right there on the plastic just there.
Right. Exactly. Just like that, and every server comes with two, like you said.
Okay. So you pop that out, and then that simply eject the DIMM.
Right. So this allows us to reach between the memory channels to actuate the latches, like so.
Yep.
And then you can just simply remove the memory.
Easy as that, yeah.
And when
Good. Yep, that's a nice touch, yeah. Okay, so that's the internals. I think we pretty much covered everything there.
We forgot the M.2.
Oh, M.2, yes, of course. So just like all the rest of the ThinkSystem servers, the SD650 also supports M.2. M.2 is a solid-state drive solution for boot purposes. So each of the servers has one installed. And there's a slot next to the memory DIMMs. And this is what it looks like here. We've got one just here. The server supports either a dual adapter, like what we have here, and it's called dual because there is an M.2 card drive on one on either side. This, as a result, this has got a RAID controller built in to allow you to configure this as RAID 1 if you want. Or we support a single adapter like the one that's installed, which has the one M.2 drive. So you could use these as a boot solution if you wanted to. Yeah.
Right.
All right. So I think that's all the components here on the inside. Now on the front of the server, let me talk about some of the components we have here. So on my side here, as I point out, the connectors here are the same as ones over here. They're identical servers. So we have on this side we have the KVM connector, I think it's called, and Scott, this is the cable. This is the cable that you would use, and basically it gives you access to your local ports, your serial port, 2 USB 2 ports, and a VGA port. So all of those connect just into there via this connector. So if you have a local crash cart, for example, in your data center, and you want to have direct access to the server, you could use this cable here to connect directly to the system. Next to that, Scott, the 2 Ethernet ports.
Yes.
This one's it's a gigabit port that's for use with the operating system. It's a regular gigabit port. Also can be shared with the systems management port. That's the xClarity controller chip that we have inside the server. So you can do systems management, out-of-band system management with that port as well. But we also provide a dedicated systems management port, a gigabit Ethernet again, for direct connection to the xClarity controller service processor.
Right.
And so you'd use this port, or in shared mode you use this one if you wanted to do remote management. Now, of course, the the KVM port is for local management. Now, I would point out too that the power buttons LEDs here, one of these LEDs is the system error light. So of course, if there is a fault in the system, you would get notified with the yellow light there. Now, this server supports light path diagnostic. That's one of its features it offers. And that means that if the LED comes on the front here to tell you that there's a system fault, you can power off the two servers, remove the tray out of the enclosure, and then there's a light path diagnostic button here when you press that button, it will light up the failed component. So if it's a faulty DIMM or some other component like that, the LED associated with that component will light up. And that is a big advantage when you're trying to service a down server.
Right.
Get it operational as quickly as possible.
Correct.
Yeah. So that's a nice feature there. Of course, there's the port for the Pcie slot there, and there's power button and the identification button. They're the identification LED, and the ID LED is that if you want to manage the system remotely, but then you need on-site personnel, you can enable that blue LED remotely, and then when the servicer comes up to the machine, he'll be able to tell which particular tray to remove and not remove the wrong one.
Right.
Yeah, that's a big advantage too when you have rows and rows of these systems.
Right.
Yeah. So I think that's about it.
Oh, and don't forget about the USB 3.0
Oh yes, of course.
port.
And finally, there's a USB 3 port for local management of the system. All right. So I think that's about it. Yeah. So there we have it. So this is the ThinkSystem SD650, our new water-cooled solution
Yes.
from Lenovo. Now, if you're looking for more information about the server, there's a couple of resources that let me point you to. There is the product guide, which has a lot of detailed information about the system, plus some pictures and drawings and lots of compatibility information. And there's also the 3D tour, which is really a very handy tool that you can actually open it up in a web browser and you can rotate the server in 3D and open components and look inside. It's very handy. And I'll provide the links to both of those in the description for the video. So there you have it. Scott, thanks very much for your time.
Oh, thank you, David.
Hope you found the video useful, and we'll see you later.